Good morning, good afternoon, good evening. Whenever you are watching this video, okay, so let us just all welcome to our channel, Future Endeavors. Today, actually, you are going to solve some numerical problems based on the concepts that you have learned in motion in one dimension. Okay, so it has been a long time since we have been not uploading any video. Sorry for that. There has been some issues regarding uh, video recording, so sorry for that. Okay, so without wasting much time, we'll be quickly moving on to the solution of two numerical problems. You can see the two numerical problems. These numerical problems have been taken from the conscience physics book class 9, okay, ICC. Okay, so let us see, you have seen two problems in front of you. So let us first do the solution of the first problem. The first problem shows that a car is moving in a straight line with speed 18 km per hour, and it is being stopped in 5 seconds by applying the brakes. So what you have to find out, you have to find out the retardation, and the second part is the speed of the car after 2 seconds of applying the brakes. Okay, so uh, let us come to the solution of the first problem. So what will be the solution of the first problem? So solution number 1. Okay, solution 1. Okay, so the very important thing is that you must write the given information first of all while solving a physics problem, numerical problem in physics. Okay, so it has been said that the car is moving with a straight line. This is the initial speed. Okay, so this is basically the initial speed. Now what will be the initial speed? Okay, so when you are talking about the initial speed, so initial speed is 18 km per hour. Fine. Okay, as it has been given in time has been given in seconds. Okay, so let us convert that speed into meter per second. So initial speed given, so what it has been given here, given first of all initial speed, first of all is initial speed, initial speed, it is generated by the letter u. Okay, so it is 18 km per hour. Now when you are trying to convert this kilometer per hour into meter per second, what you have to do, you have to multiply this term 18 by 5 by 18. Okay, so 18 multiplied by 5 by 18 gives the speed in meter per second, so it's 5 meter per second. Okay, now what else has been given? Time has been given, it is stopped in 5 seconds, so stopped. Okay, so obviously the final speed will be 0 meter per second. Final speed divided by the letter v, it will be 0 meter per second. Okay, now another thing, retardation, and the time taken for this is 5 seconds. So time taken, it should be denoted with the t, it's 5 seconds. Okay, fine. So these things have been given. Now the first part of the problem has been said that what is the retardation. So you can see from the definition of acceleration, you know that acceleration is actually change in velocity by time. So retardation is nothing but the opposite of opposite of acceleration. So retardation is just opposite of acceleration. So here we will be seeing retardation will also be the change in velocity by the time taken. Okay, so retardation, so retardation is actually the negative of acceleration. Okay, therefore retardation equals to negative of acceleration. Okay, so what is the acceleration? Now acceleration a is equals to final speed 0 minus initial speed 5 meter per second by time taken 5. So this turns out to be minus 1 meter per second square. Okay, so as retardation is negative of acceleration, therefore retardation is actually 1 meter per second. Retardation is nothing but is equal to 1 meter per second square. Okay, fine. So this is the retardation. Now you have to find out the speed of the car after 2 seconds. Okay, speed of the car after 2 seconds. Now see, actually it was moving with a speed of say 5 meter per second. Now after, so if we consider the speed of the car, if we just consider the speed of the car, okay, is it visible? Okay, so you can consider the second part. This was the first part, this was the first part. Okay, this was the first part. Okay, now the second part, we have to find out the speed. So let speed after 2 seconds 2 seconds we say v dashed. Okay, v dashed. Therefore from the definition of acceleration you can write a is equals to v dashed minus initial speed 5 by the time after which it has been asked to find out the speed is 2 meter per second, so it's 2. Okay, fine. Now see, the acceleration is actually minus 1 meter per second, so you can write that this implies that minus 1 is equal to v dashed minus 5 by 2. So this turns out to be v dashed is equals to minus 2 plus 5, so it's 3 meter per second. Okay, so this is the speed of the object or speed of the vehicle after 2 seconds. Okay, so I hope the solution is clear to all of you. Okay, solution. Okay, if you have any query, please do mention it in the comment box. We will be happy to solve your problem or query, any doubt. Okay, now coming to the solution of the second problem. Okay, so again we have to first of all write what are the given things. Okay, so let us just see what are the given things. Okay, solution 2. Okay, so what are the given things? Let us see. It is very important to write down the given information while you are solving a problem in physics. Okay, so car travels first 30 km with a uniform speed of 60 km per hour. First 30 km. So distance is generally given by the denoted by the letter S. Okay, so first part of the distance, first part of, you can say, displacement, isn't it? First part of displacement, so it's in bracket, let us take it as S1, is equals to 30 kilometer. Okay, 30 kilometer. Then it is traveling the speed of 60 km per hour. So initial first speed or velocity. Okay, so first velocity, say let us denote it as v1, is equals to 60 kilometer per hour. Okay, fine. Then next 30 kilometers, so let us consider to be second part of the distance, so 30, and speed is 40 km per hour. So second part of displacement, so its bracket S2 is again 30 kilometer. Okay, and basically the first second velocity is equal to, you should take it as v2 is equals to 40 kilometer per hour. Okay, 40 kilometer per hour. Fine. Now what we have to find out, we have to find out the total time of the journey. Okay, so for the first time, initial time taken to cover the first part of journey. Okay, so we are solving the first part of the journey. Time taken to cover the first part of the journey, let's take as t1. We know that speed equals to distance by time, so time equals to displacement by speed. So its displacement is 30, speed is 60, so this is nothing but half hour. Okay, and time t2 is equals to, again, distance by time is equals to speed, so time is equals to distance by speed, so it's 30 by 40, this indicates 3 by 4 hour. Okay, so total time of the journey is nothing but summation of t1 and t2. Okay, so this turns out to be half plus 3 by 4. Okay, so LCM is 4, 2 plus 3, that is equals to 5 by 4 hour. If you convert into mixed fraction, it should be 1 by 4 hour. So this is the total time of journey. Second part has been said, that what is the average speed of the car. So average speed is nothing but the total distance by total time taken. So average speed is total displace. Here it has been set speed, so just consider this as the total distance. Okay, so total distance, here you are considering the displacement and distance to be same, okay, by total time. Okay, so distance is 30 plus 30, 30 plus 30 plus 30, so that turns out to be 60, and total time is 5 by 4, 5 by 4, 5 by 4. Okay, so this turns out to be 60 into 4 by 5, 5 12 is 60, so it's 48 kilometer per hour. So this is the average speed of the vehicle. Okay, so I think the solution is clear. Okay, so with that we come to a end of this video. In the next video we'll be discussing about some more problems from the next part of the chapter. Okay, so till then, please do take care, and if you have any query, please do mention in the comment box. Thank you. Tada.